Hello, everyone, and welcome to the presentation from Avineon on GeoBIM. This is the geospatially enabled building information modeling. And in this presentation, I will discuss our experiences using FME with GeoBIM in the United Arab Emirates. My name is Mike Chenevey. I am the GIS Business Development Manager in the commercial systems for Avineon USA. Just a little bit about Avineon and Tensing, which is our Netherlands company. Safe Software Silver Partner since 2017, over 30 years experience with data integration. We are one of the best in class certified FME teams worldwide, globally. And we can offer FME licensing, resale, FME consulting, and we have a number of FME projects in process right now. And we also offer a full suite of FME training. And that could be done remote, of course. We have locations throughout the world in the United States, Canada, the Netherlands, India, France, Belgium, and the United Kingdom. Here's our agenda for today. First, we're going to be talking about the project scope. What were the solutions that we offered? What were the business needs and project objectives? Implementation for the BIM, the GeoBIM, and also a 3D city model that was developed, and key challenges and the business value. So each one of those we'll be covering in the forthcoming slides. Now we'll talk about the business needs versus the project objectives. First of all, some of the challenges faced by the client prior to this project include building plan drawings from developers and contractors that were received only in the form of 2D CAD drawings using non-standardized templates, which made it very time-consuming to search and find the required information for issuing building permit approvals and building code violations. In addition, the city and urban planning involved a lot of manual effort since it was difficult to validate new building plans against the established building standards. It was also not possible to visualize building elements in a 3D environment, which made the validation of legacy building design modifications requests quite challenging. And the archived 2D CAD and paper plans also complicated data mining and analytics because of the unavailability of a GIS-centric and holistic view and the lack of a centralized database for the urban components. Think, for example, on shadow analysis, energy demands, noise exposure, etc. Now, for the project objectives, first we had to create a BIM platform or framework to model the existing and future buildings and help promote a GeoBIM-based design culture. We also facilitated contractors, developers with predefined specifications and templates for the submission of their BIM and CAD drawings at different levels of detail to ensure the submission of BIM-compatible drawings in the future. Also, we had to establish a complete GeoBIM database of all major buildings by converting legacy CAD plans into an architectural BIM model in LOD 300. For this, Avineon converted 15,000 buildings into 3D architectural BIM model, the LOD 300 level, design, development, and we also converted one building into LOD 500, which is as-built level. All of this leveraging FME. We had to have a set of customized functions that would support the building design validation process. And then we built a web viewer for GeoBIM integration with a 3D city model, which provides a holistic view of the city and thus enables data mining and analysis. Avineon geo-enabled and developed this web application that allows the viewing of the 3D BIM models. So let's talk a little bit about the plan. What was the plan to meet these objectives? Well, in the development stage, we needed to define the LOD 500, the as-built quality BIM data model and building elements. We also designed the LOD 500 based BIM template drawing in Autodesk Revit. And then also we designed LOD 300 based CAD drawing template for all the architectural elements. So they would be in compliance with the BIM requirements. And then we defined the technical specifications for LOD 300 and 500 to be followed by all contractors and consultants in the future when they submit drawings that would be incorporated into the BIM model. As far as the BIM services, here we created the LOD 300 architectural Revit models for over 15,000 buildings using the CAD files and also PDF documents. We created LOD 500 Revit model for one building, and that building included all the MEP elements, the mechanical, electrical, and plumbing, as well as all the architectural and structural information. And also we implemented ArcGIS enterprise-based BIM viewer application. We designed, developed, and implemented that, and as well as a customized tool for automating the conversion from CAD templates, or the CAD templates that we developed, to Revit, and then a validator tool for the quality control validation on all the submitted CAD files. I'm going to be showing you a bit of a workflow so you can see all that in a little bit. And then the geospatial elements. We loaded all of the LOD 300 BIM model data and published them to the web as multi-patch geometry scene surfaces. FME was used as well as a customized tool that we built for migrating from Revit to Esri geodatabase. And we provided as well all of these spatial analytical tools and functionalities built into the web application to be able to search, query, do custom printing and filtering. And then at the final stage was the 3D city modeling for key areas of the city in LOD 2.2, the term used for 3D city models. And this was modeling 3D buildings and landscape for all the key areas of around 180 linear kilometers, including about 40,000 buildings for the city model. We also modeled additional features such as bridges, commercial signs, and point features like trees and poles. There were over 7,000 buildings included in that modeling, 8,500 poles, 30,000 trees, and 1,000 commercial sign types. And we delivered this information in City GML output for publishing everything to the GIS application. And this is where FME came in for the 3D modeling effort. We'll talk about that. And then end user training, of course, was included as part of this. So let's take a look at the approach in workflow fashion. So here we have the initial part of this was the input data was the as-built CAD files, drawing files. These were floor plans in drawing files and also drawings in PDF. So we needed to convert those, all this what we call legacy data from drawing files to Revit, and then also converting the paper files with PDF directly to Revit using specialized tools. And then the data was in Revit that direction. Then the new designs for contractors submitting data, we developed the CAD template for the contractor. Then the template data to BIM drawing, and CAD to BIM validator tool, which was then imported into the conversion process. And then over here on the GEO-ENABLING BIM and application development, here's where we leveraged FME and some specialized tools that we built to convert Revit to ArcGIS. And then, of course, used ArcGIS Pro to publish that to a web using the Enterprise GIS web application, and also FME at the stage to convert all the Revit data into City GML for the city 3D model. And the last step there, the 3D modeling for the city, was loading all of the data into Rhino City for texturizing, and then using FME to convert the city GML to ArcGIS. And we use City Engine actually to publish these things to the web tier, and leveraging this ArcGIS Enterprise web application. I'm going to show you that in a minute. That is the workflow. This is an example of the GEO-enabled BIM
This is LOD 300, and I'll show you 3 images here. At this level, this was the CAD raster floor plans that were converted into the BIM template. We modeled 7 to 9 key architectural elements in LOD 300. So things like columns, walls, doors, windows, floors, roofs, stairs, railings, and ramps. That was all LOD 300. For the LOD 500, this captured much more detail. So these elements that were captured are the MEP. We talked about that before, the mechanical, electrical, and plumbing for this building. And this included things like lighting, HVAC systems, water and drainage, and fire safety. So all those things were incorporated into that LOD 500 BIM model for the one building. So let's take a look at the CAD to BIM migrator, this tool. This is based on AutoCAD templates. We developed validation tools to ensure that the CAD data met BIM requirements. And this involved a multi-floor conversion, as you can imagine, and you saw part of it earlier. Also, taking a look at some of these images, the CAD data was migrated to BIM using our templates, the CAD and BIM templates, which also maintain all the relationship and attributes needed for the feature to get migrated as a BIM object and then later to the GIS. This converter, the BIM to GIS converter, ensures that all the future relationships stored in BIM will maintain themselves, like complex elements. Railings and stairs, which hold multiple objects, are a good example. So for the GeoBIM migrator, this is showing the FME, Revit, Esri technology-based tool. We used all 3. The tool converts Autodesk Revit models into Esri enterprise geodatabases. This gives the ability to integrate attributes from external sources and gave us the ability to convert multi-floor buildings really very fast. And then secondly, here on this other image, Avineon BIM to GIS tool. This was custom built on using the FME plugin for Revit. And we also added some additional custom code. At the time, this was a couple of years ago, using ArcObjects and .NET, which converts BIM objects to an Esri enterprise geodatabase, and then also the enterprise data store. And it stores it as 3D multi-patch scene objects with attributes. And then those were published as scene services in ArcGIS. The BIM to GIS tool can support both IFC and the RVT, RVZ format from Revit through FME to migrate to ArcGIS Enterprise. And that way the BIM viewer could consume all this data and provide the analytical query and view tools to the end users through browsers. Let's take a look at this BIM viewer, the GeoBIM viewer, and what it looked like. So here's some examples. The GEO-enabled BIM viewer application provided these advanced analytical tools I've been talking about. They support the LOD 300 and 500, this for the web application did. The technology here is Esri's ArcGIS Enterprise 10.6 using ArcGIS JavaScript API and Web App Builder. If we take a look at this next image, we can see that you can choose a building with a certain number of floors. We can display a selected floor and see the floor plan view. We can query attributes and essentially slice up the building and take a look at it inside. And then this view shows some of the advanced spatial analytics where we can do analytics by geographic area. So because there were so many buildings involved in this project, this involved data analytics on a much larger scale. The refreshes, for instance, are handled by replacing all the old versions of the BIM model features, the per building or floor basis, with the latest updated model features. So to do updates on these things, it's wholesale replaced. And all the features that we have in here carry unique building floor IDs. And then we handle the data loading back on the back end and noticed that we had very efficient timing when we loaded even 2,000 to 3,000 models at a time. And it took about 2 to 3 hours to load initially, depending on the size of the building, to create the model in the first place. This is a great example of the bill of quantities I mentioned earlier. So that's a document that provides specific measured quantities of the different building elements. And here you can pick on a particular building, a particular floor, particular area of a floor, and have it give you all of the elements and object types associated with that area. And this is all done through the web application. This view, you can see that building rules can be validated. For example, if you wanted to see where the exit door count in a building is less than 2, you can do that using a search, and it'll tell you which buildings meet that criteria. You can also do material analysis across buildings and by geographical area. And then you can do a cooling demand analysis. This is a little tool that we built that reads the BIM model and calculates the area. It has configurable parameters, and we can also consider the solar calendar of the area. It's built into this. So you can provide an energy classification for each individual building that you want to run this information on. And then at a smaller scale, as we back out a little bit, we can see that you can integrate, and we have integrated utilities with the BIM data. So you can see under every building and citywide underground utilities and where they are relative to the buildings. On the city modeling side, I mentioned this. This is where we do the 3D 2.2 LOD city model. We did this for certain key areas of the city. The imagery is based on Worldview 3 satellite imagery with a sensor resolution of 30 centimeters. And then we did all the texturing and all these different images of poles and trees and bridges based on the NC Tech Pulsar system. The sensor resolution here was 60.5 megapixels, and it would capture images in a 360-degree manner from 4 fisheye lenses. So these high-resolution images provided photorealistic textures to the buildings. The viewer supported the multi-patch textured models, and so you can do this advanced spatial analytics. It also supports city GML modeling, and you can see here, for instance, line of sight analysis. So you can do point-to-point or area-based options. Inside this web application, you can do, you can change your elevation, you can do proximity analysis. It'll give you a detailed list of buildings, and everything is integrated with the building database. This shows an example of a solar potential calculator that we built into the viewer. So it's, it can give you dynamic panel layout options. There's multiple standards that could be used with this. And then this image here shows that the BIM is integrated with the 3D models. You can pick a building and get information about any building that's in the system. And then we also built a virtual reality kind of concept into the viewer, so you can fly through and also do like a bird's eye view with dynamic paths to set up different points and then fly through those paths. So that's the essence of the project, but I wanted to talk a little bit about the key challenges that were overcome to get all of this work done and build this the GeoBIM. First of all, it's basically the first one here telling us that we believe it's an unprecedented project. We don't think there are any other projects of this scale that have been done to date in the Middle East. So there was no precedent. Secondly, even the current technology framework in 2021 and the platform don't completely provide a seamless interoperability between the Esri tools and the Autodesk Revit. For particularly the high numbers of heavy BIM data we were dealing with, 15,000 buildings. So we used FME quite a bit. It was a workhorse, and also the plugin that SAFE has for Revit was very helpful. We use IFC format here. And this was supplemented with some additional custom coding because we wanted to make sure that all the attributes were confirmed as we were loading data. And every now and then it seemed like there were some redundant fields being generated. And so we were able to go through and kind of do quality control with some additional custom coding. But FME was like the workhorse into this thing, which really helped. Number 4, Avineon did develop some customized methods and tools for overcoming some challenges we had with the IFC format in migrating the Revit models to GIS. And then number 5, there were some limitations we found with creating data stores using for ArcGIS Enterprise for publishing massive multi-patch geometry scene services. So we devised a workaround method for overcoming the publishing challenges. And what were the business value and benefits to the city in the UAE? First off, we developed all of these published standards, templates, and specifications. So in the future, all contractors are submitting building designs in the BIM up to LOD 500. All the templates are in place. And secondly, they can do their building permit process by visualizing the buildings in the BIM before approving their designs. Third, all of the building standards and code validation tools can help automate it and do help automate validation of all the building rules. So they can ask questions and query by floor, by building, and have this information geographically aligned. Number 4, there was we built an automated process for converting all the 2D CAD plans into the 3D Revit BIM drawings. And that still exists and is useful. Number 5, we built automated tools that enable the quick conversion of BIM drawings into GIS, leveraging FME here again. Number 6, the web application that we built enables and authorized government users, enables them to see this building information in web browsers. They're in their own secured environment, so that works. And of course, it federates access to all of this information for the purpose of their planning and permit process and other types of analyses that they would want to do. Number 7, the web application also enables the users to run and get data mining, business analytics across multiple buildings and even regions of the city. Well, for instance, be able to get the BOQ that I mentioned before, the bill of quantities for buildings on the fly. And then 8, the BIM output leverages FME and developing that textured 3D building look and feel, and also the virtual reality views. All of that leveraged FME to be able to do all the data input to the texturizing applications and make it look very realistic. So that is it for the presentation. I wanted to thank you. This is my contact information. Again, my name is Mike Chenevey with Avineon. And now we're going to open this up to questions. Thank you very much.